Hello everyone. Uh, Today I will discuss stereoelectronic effect in E2 eliminations. So first we will try to understand what is a stereoelectronic effect. The effect of spatial arrangement of orbitals and atoms on the reactivity of the compound is generally known as the stereoelectronic effect. So, what is the spatial arrangement of orbitals and atoms and how they affect the reactivity of the compound is known as the stereoelectron effect. For example, the preference of anti-periplanar arrangement of hydrogen and halo in transition state of for the E2 eliminations. As we know, when the E2 elimination happen, when these hydrogen and halo are opposite or anti-periplanar to each other, the reaction rate of reaction is faster and E2 elimination takes place easily. So this is an example of stereoelectronic effect that we know in the E2 elimination. So by knowing this stereoelectronic effect, the question comes in our mind. So the question is what cis what is questions? Uh, Cis 4 tertiary butyl cyclohexyl bromide, we have this one, and second compound is this trans 4 tertiary butyl cyclohexyl bromide, in which will be the rate of reaction of E2 elimination will be faster. So this we will try to understand by this mechanism. So we have drawn here this cis 4 tertiary butyl cyclohexyl bromide. So what will be the stable conformer of this? This is a stable conformer of cis 4 tertiary butyl cyclohexyl bromide. So why this is stable? So this is bromine at the axial position and this tertiary butyl as the equatorial position. Because this is the bulkier group, when will be this equatorial position, then it will be the stable conformer. There is another conformer we can write like this. We can write another conformer of this bromine is equatorial and this is axial, but this conformer is a less stable. Okay, so we have to so it will so we if we have cis tertiary butyl cyclohexyl bromide, it will prefer to exist in stable conformer. So we have written here the stable conformer. So when it will react in the potassium tertiary butoxide in tertiary butanol, E2 elimination will happen and this tertiary butyl cyclohexene will be formed. This will be our product. So in the next second case, when we have trans 4 tertiary butyl cyclohexyl bromide, this trans 4 tertiary butyl cyclohexyl bromide, we have written this structure. This is a trans. One is the below the plane bromo, and this is above the plane tertiary butyl. This is the trans. So what will be the stable conformer of this? When same in the similar way, this tertiary butyl is in equatorial position, and now because this is a trans isomer, so this bromine will be equatorial to this tertiary butyl because we have to write a trans conformer. So when we will write the trans conformer, both will be at the equatorial position. So when this 1 and 4 position both are equatorial position, then the trans isomer. When in this 1 and 4 position are axial or equatorial, this will be the cis isomer. So this is a stable conformer of this. This is a stable conformer. Okay. So in this stable conformer, this hydrogen and bromine are not in uh, axial position or not are in the anti-periplanar position. So what we know, for the E2 elimination happen, both should be in anti-periplanar positions. So here E2 elimination will happen if this structure we have. So this will, for before the E2 elimination happen, this have to convert in the less stable conformer. First it will convert in less stable conformer. So in the less stable conformer, this tertiary butyl will come at the equatorial position, and this will be as the equatorial position, because these both are this trans isomer. So 1 and 4, when the axial and one position and 4 position at the axial axis, then it will be the trans isomer. So when this now the trans isomer will react with the base in the presence of tertiary butyl alcohol, it will give the our uh, tertiary cyclobutyl, tertiary cyclohexene, tertiary butyl cyclohexene. So it will convert in the stable conformer. Okay, so now we have seen when the trans isomer will react, the product will be the it will directly convert to the product, our desired product. But when we have the trans isomer, first it have to what we will get the stable conformer. Then first stable conformer will convert into the less stable conformer, then it will react, and further it will give our desired product. So what will happen in this, that in the case of the trans conformer, first has to convert in the less stable conformer. So this is the slow step for this reaction, because this is it's very difficult to convert in the less stable conformer. So from this reaction mechanism, what we have learned in the E2 elimination, in the cis isomer is 500 times faster than the trans isomer, because in the cis isomer it is directly E2 elimination happening through the more stable conformer. So now what is the reason for this? Because the trans isomer has to convert the less stable conformer, so E2 elimination is low in the trans isomer. Okay, now we have learned in which will be the um, uh, a more fast reaction, cis isomer or trans isomer, and what is the reason for the faster reaction in the trans isomer? It is the stereoelectronic effect that governs the formation of faster product in the cis isomer. Thank you.